Hi, in this video we will talk about how to take the correct significance figure or decimal place, that is to say round up or round down to which digit in our mathematical calculations. Okay, so let's look at the first one, which is 45 times 711. Okay, so if you try to use your calculator, you will be able to find the answer as in 31995. However, we should not express it with the whole number. Okay, if you are doing the final answer. Of course, if later on you have to calculate some other things, then it's totally fine. You can take this whole value. But then if say in the exam when you are presenting the final answer, then you should not express all these 5 digits. So what you should do, and the rule it should be is probably something that you may have heard in IGCSE too, but let me just reiterate again. For multiplication and division, what you have to do is by looking at your raw data of how many significance figure of them for each raw data. So for example, here 45 you have 2 sig fig. For 711 you have 3 sig fig, obviously. And so the rule is for your final answer you can only express with the least sig fig from your raw data. So that is to say your final answer should be expressed as 32000 only. Okay, and in fact the best of presentation in physics should be using the scientific notation, because if you write down 32,000, we actually don't know whether it is 2 sig fig. It could actually be 3 or 4, 5 sig fig as well. So the best way of doing it would be 3.2 times 10 to the power of 1, 2, 3, 4. Okay, so this should be the actual final answer instead. Okay, so let's try to apply this idea to the next question. So next question as in this one. So you can see that I modified the question from the previous one just by a little bit. So each number has a 0.5 of increase, and I'll explain to you why I make such a change. If you use your calculator, you should find a number like this, which is 32373.25. Okay, I just copied the whole number. So according to what we talked about just now, since this one is 3 sig fig, this one is 4 sig fig, then you should take the least sig fig once again. So I could only take 3.24 times 10 to the power of 1, 2, 3, 4. Again, of course. Okay, so obviously then now you can see your answer comparing to the previous one. You have one more digit, one more sig fig. The most important thing that I would like to show you instead is the reason why we have to do this at the end of the day. So why do we have to take the least one? Why can't we just take one more? So think about this. When you look at the first question, the answer that we calculated is 31995 from the number of these two. And so when you look at a certain number in physics, remember we are dealing with the physical world problem. So all the numbers, well not all, but then most of the parameters that you get, you should assume is like getting from an experiment. So say you somehow measure 45 and somehow measure 711, and you want to get to calculate something, then when you try to measure 45, it actually means that it is plus or minus 0.5 probably, or even plus or minus 1. So I'm trying to show you that what if it's in the worst case, because when you say 45, actually it might actually be 45.5 or 44.5, yeah, and then you kind of round up, or 5001. Okay, so then you round it up to 45. So this could be the worst case. So the second question right now is just simply showing you the worst case simply. So if you try to compare the answer here and the whole number from your first question, then you see that you only get to match the first two significance figure, that is 31, but actually it's 32 because you have the 9 that round up to this, so it's still 32. And in the second question, it will be also 32 obviously. So that is how you only can take 2 sig fig in the first question. Think about this, if you don't follow this rule, okay, if you don't follow this rule, and if you just want to somehow take one more, then what you have is, you will have still 32 you may say, but then it actually become 320, right? Because you are taking one more digit, right? So 320, that is one more digit, one more sig fig. However, if you look at the question 2 that we are calculating, again, this is a worst case. If you do that, then it doesn't make sense, because when you take up to the 3 sig fig, it's actually 323, right? Or 324 instead, like the answers that you have in the second question. So the third digit, or the third significant figure, is actually not reliable for you to take in the first question. So I hope this simple example between these two calculations can explain to you why we have to follow such a rule, taking the least sig fig when you do multiplication. And in fact, this applies the same to division as well. Okay, if you still don't trust me, let's try one more pair example on the right hand side. So it will be to the power of 4, so it's kind of similar to multiplication. I mean, it's actually multiplication as well. So obviously, if you try to interpret this, this is the same as 23.4 times 23.4 times 23.4 times 23.4, 4 times, okay? And this taking up so much space, I'm going to erase it, okay, just to show you an idea that you may have forgotten since primary. So when you press the calculator, once again, let's do an investigation here. You have a really long digit like this, and so that is 29982.1.9536. Okay, I just try to copy as many as I can from my computer. Of course, I do think it's not just stopping here, but it's probably just infinitely long. Anyway, according to our rule, once again, then how many sig figs should we take? I give you 5 seconds to think about it. I hope you didn't say 1 sig fig because of the index here, okay? So the reason is, remember, we are always dealing with a physics problem using mathematics. So the 4 here we are talking about is 23.4 multiply itself 4 times. And these 4 times has no error at all. You can't say, oh, it has an uncertainty of 0.5, so it could multiply itself for 4.5 times. You can't do that, right? This is a real purely mathematical number, doesn't involve any experiment or physical parameters. So what you can think of instead is just simply 25.4 itself. Okay, so that's why the answer can only express with 4 sig fig instead. So I guess the answer will be 3, because rounded up, so 3.000, actually no, it's actually 2.9. I don't know why I think that. 2.998 times 10 to the power of 2 instead. Okay, so that's the first one. The next one you can see is that you again have one more digit with an addition of 0.05. So this is, once again, I want to show you like what I did earlier, as in for the worst case that you might have for 23.4, that you could actually be having plus or minus 0.05, all right, or 0.1 even, right? But then I'll just do a smaller one. So in this case, then let's see whether or not we could have taken more sig fig. So once again, let's just use our calculator to find out the exact value first. So for this one, you can see it is 302,392.7595. Okay. So you will find out that this is quite different from what we have in the upper question. So no matter what, let's just see what we have first. All right, if you take 3 sig fig. Oh, by the way, I don't know why I took 4 sig fig. Actually, I should take 3 sig fig for a previous question. So yeah, I was right. I was right. I was right. That I should only take 3 sig fig. So yeah, actually I don't know what I'm thinking at all. Sorry about what happened just now. 1 2 3 4 5, so actually be 3.00 because we only take 3 sig fig because of the original number 3 sig fig, so 3 sig fig only, and then you round up to 3.00 and then 5 here, order of magnitude. Okay, sorry about that. All right, no wonder I feel so strange just now. Okay, so in this case, second part of this question, then you have 4 sig fig in the raw data. So in this case, that means you can only take up to 4 sig fig. So 3.024 in this case, also 10 to the power of 5, of course. So the interesting thing is you find out even for this one, in fact, taking 3 sig fig in the first part is actually not quite justified as well, because if you look at that, the way that we took 3 sig fig is according to the rule that I mentioned earlier, right? So that's why this is 3.00. But then if you look at the lower part of this question, we got 3.024. So let's disregard the 4 first, right? Because that is of course not like out of the topic already. But then why do we still have 2 here? All right, so you may ask, so shouldn't we take maybe only 2 sig fig, right? So so that in this case we can make our answer more justified. I would say yes, actually. I mean, if we could, we probably it's better or more accurate to show 2 sig fig only in the upper question. All right, so the so-called rule of thumb or the method that I said, least sig fig from the raw data, is just really a rule of thumb. So that is to say, a general approach. It doesn't mean it is 100% correct in all situations. However, it is good enough to help us to justify the precision of our answer, and this has been widely used among all the physicists. So that's why you could still follow that. Alright, so we are all good with the rule right now. So let's do the division also. So here with the next question here, using your calculator, you should get a number like 2.619230769. Okay, and again, according to our rule, we take the least sig fig. Here we got 4 sig fig, here we got 3 sig fig, so the final answer should only be taken with 3 sig fig only. So that is 2.62 only. Alright, that's it. Similarly, for the other one, you should interpret this as 9876 to the power of 1 over 2. Once again, 1 over 2 is not an experiment value, so it's just purely 0.5 or 1 over 2, so you don't have to think about the sig fig of that. So what you could do is simply just have 4 sig fig in this case, because original number has 4 sig fig. So if you find out the whole number, it will be 99.37806 blah blah blah, and then you should round it up to 4 sig fig, so that is 9.938 times 10 to the power of 1. Okay, that's it. Okay, so now we'll go into the plus and minus. In fact, these are slightly more complicated than times and divide, because those are relying on significant figure. For plus or minus, it will rely on the decimal place instead. So let me show you an example. So for the first one, this question here, when you press the calculator, you will get the whole number as in 489.54, and the rule of thumb is you again would take the least decimal place. Okay, so for this one, it has 1 dp, this one is 2 dp. Remember, dp, right? Not sig fig anymore, nothing to do with sig fig for now. So in this case, we can only take 1 dp again for the least dp. So 489.54 5 only. You may ask me, hey, why do we have to follow this? What's the rationale of this? All right, I hope you asked this question. So let me use a space down below here because I'm running out of space. So say the number that you have from the question, you can rewrite it vertically like this. All right, so that's how you can get the final answer as this, right? So this is exactly like what you do in primary. But then the problem is, in physics, we are in fact not sure about the digit before, after 2 here. You are not sure at all. So if you think about these so-called something or question mark plus 4, these 4 actually should not be there unless the question mark there equal to 0, right? So in this case, obviously, this digit is not reliable at all. So that is why we don't do that. That's basically is the reason. You may further argue that why do we take this one then? Because if the question mark is actually something like, say, 7, then you have like 11 and then you plus 1 here. So this will become 6, right? Then yes, I will agree. Yeah, this may happen. However, I think just like the previous case when we talk about multiplication and division, there are cases like on the right hand side here, it doesn't perfectly keep you safe. All right, so it's a compromise of having a realistic number of decimal place or significant figure while keeping the information sufficient enough for us to work. Alright, so let's just finish the rest of them very quickly since you should have mastered the idea already. So for the next question here, you don't actually need calculator because if you just add them for the whole number, it would just be 0.705040. Okay, but then if you think about the rule that we talk about here, this is 1 dp. The one at the front is actually 1, 2, 3, 4, 6 dp. Doesn't really matter because our rule told us that we have to only take 1 dp. So that means the answer is just really 0.7. Okay, in physics. This question also tells you an idea that in your future experiment, when you try to measure something, it is actually quite important if you want your final result to be precise. All the measurement has to be precise to the similar level. So that is to say, if you have one of the important measurement to be not as precise as this one, like 0.7, it kind of ruined the other measurement as well because of this, it kind of dragged the level of the precision down to 1 dp, right? So no matter what you measure for this one, like in the front 0.005040, it's very precise measurement, but that is useless, right? Because of the other measurement is not precise enough. Okay, so for the next question, using your calculator, you should find the number of 27.363. Once again, by the rule that we talk about, this is 1 dp and this is 3 dp. Okay, so we can again only take 1 decimal place. So that means we will round this answer to 27.4 only. Okay, and that will be the final answer simply. Okay, lastly, we have a number like this. So we will have 12500 minus 36. So you have a whole number of 12464. For this question, we have to think more carefully because it really depends on the decimal place or significant figure as well on this. So are we actually measuring this really up to 1.2500 times 10 to the power of 4, or do we actually have 1.25 only? So that 0 is actually negated times 10 to the power of 2, because that actually makes a difference. So my point is similar to what we have in the sample here below. So if you try to write in a vertical calculation, then you have 12500 for this case, right? You get all the 0, and then you have to minus 36 to get the whole number. So in this case, then yes, definitely, then I will go for this answer. Okay, if you really have 10 to the power 4 in this case. However, if you only know and sure that the first 3 digits, and that is to say the number is actually 1, 2, 5, question mark, question mark. You're not sure about the last 2 digits. And if you try to minus 36, you cannot do anything, right? So in that case, your answer would be 1, 2, 5, 0, 0 only, right? You may find it's ridiculous because when you have a number minus another number, like A minus B, it will still equal to A, right? It is ridiculous, but then it is what it is, according to our understanding and the logical thinking of the validity of your number in physics. From the last examples here, I hope you really understand the reason why we always emphasize using the scientific notation is always the best to show how many sig fig you have. Because as you can see, when you write down 1, 2, 5, 0, 0, it's ambiguous, right? It's very vague. So it's always the best if you can specify the sig fig that you have, and that would help us to deduce a much more accurate and justified result other than just blind guessing.